Hello friends, I welcome you in lecture number 8 on random variables. In previous lecture we have discussed how to find out mean or expected value of a discrete random variable. Today we are going to discuss about variance and standard deviation of a discrete random variable. So first we define what is variance of a discrete random variable. So suppose x is a discrete random variable with probability mass function p of x, and suppose expected value of capital X is mu. Then the variance of x is denoted by these different notations: var of x or v of x or sigma square. This capital X indicates that this is variance of random variable capital X, or sometimes we can simply write sigma square also, and is defined as expected value of square of x minus mu. So this x minus mu represents the deviations of values of random variable from mean, and we are taking square of these deviations. So this is nothing but sigma square of deviations, that is square of x minus mu into value of corresponding probability mass function, and for each value of x we have to consider these deviations and then we have to take their summation. So this is by definition expected value of x minus mu whole square. This is nothing but variance of random variable capital X, and if px is given, we can find out variance of a random variable using this formula. The standard deviation of capital X is denoted by sigma x and is nothing but square root of variance of a random variable x. So standard deviation is nothing but square root of variance of x. So we can write it as square root of sigma square. Now the variance of a random variable x is a measure of dispersion or scatter in the possible values for capital X. If we have probability distribution, then the scatteredness of that probability distribution can be measured by variance or standard deviation. So this is one formula of variance of x. It is variance of x equal to expected value of square of x minus mu, that is sigma x minus mu square into px. So we can rewrite this formula to obtain another shortcut formula also. So we see what is that shortcut formula. By definition, variance of x equal to expected value of x minus mu square, that is nothing but sigma x minus mu square into px, and we recall that mu is nothing but expected value of random variable capital X and is defined as sigma x into corresponding value of PMF. Summation is for all possible values of random variable. So this mean is used here, mean of a random variable. This is the mean of a random variable or expected value of a random variable. So x minus mu square into p of x. Now if we expand this, it is going to be x square minus 2 mu x plus mu square into px. So now we can expand this summation. It is summation x square into p of x minus second term is going to be minus sigma 2 into mu into x. But here 2 into mu is independent of and here of course we have to multiply with p of x. Okay, first we are taking sigma x square into p of x, that is this summation. Second summation is minus sigma 2 mu x into p of x. Now this summation has variable x. The variable of summation is x, so this 2 mu is independent of x, so we can take it outside, and into sigma x into px. Similarly, last summation will be sigma mu square into p of x. So here also mu square is independent of x, so we can take mu square outside and we will have sigma px. Now this is nothing but expected value of x, as I discussed here. Sigma x into px is nothing but expected value of x or mean of x. So we replace it by expected value of x. This is nothing but expected value of x square. And summation of all the values of PMF is always 1. That is property of PMF. We know that summation of p of x for all possible values of x must be 1. So this summation is going to be 1. And we replace expected value of x by mu. So it is going to be minus 2 mu square. This is as it is. This is mu. So mu into mu, that is mu square, and plus mu square. So finally we obtain this formula for variance of capital X. It is expected value of square of random variable minus square of mean of random variable. Expected value of x square minus mu square. So either we can use this definition to find out variance, or we can use this shortcut formula also. So to use this shortcut formula, we have to first find out mean of random variable, and then we can find out expected value of x square, and then their difference is nothing but variance of x. So let us take one example. Let a random variable capital X denote the outcome of throwing a fair die. Find the variance and standard deviation of this random variable. So here random experiment is throwing a fair dice. So there are 6 possible outcomes, and capital X denote the outcome of throwing a fair dice. So the possible values of x are 1 to 6, and for each outcome, the probability of each outcome, suppose I want to find out PMF for x equal to 1, then I have to find out the probability that x equal to 1 occurs. So there are total 6 possible outcomes, and the probability that 1 occurs is only 1. So it is 1 by 6. Similarly, for each value, the probability is going to be 1 by 6, because the outcomes in favor of each value is only one outcome. 2 occurs. So if we consider the event that 2 occurs, capital X equal to 2, then the outcomes in favor of 2 is only 1. So for each value of small x, the corresponding value of probability mass function is 1 by 6. So PMF can be written as P of x equal to 1 by 6 for x equal to 1 to 6. So now we find out we require variance and standard deviation of x, but I want to use this shortcut formula. So first I will calculate mean of a given random variable. So by the definition, mu equal to expected value of x, that is sigma x into px, and the range of random variable x is 1 to 6. So we write x equal to 1 to 6. Now p of x is 1 by 6 for each value of x, so we can put px equal to 1 by 6. Now in this summation x is variable and 1 by 6 is constant. So we can take 1 by 6 outside. So we will have sigma x, where x is from 1 to 6. So this is nothing but sigma x is, this summation is nothing but 1 plus 2 plus 3 plus 4 plus 5 plus 6. And if you recall the formula for sum of first n natural numbers, if I consider first n natural numbers, sum of first n natural numbers, then you may recall that this is given by n into n plus 1 divided by 2, where n is natural number or positive integer. So using this formula we can find out this sum by taking n equal to 6. Okay, here we add up to n equal to 6. So here we will put n equal to 6. So we obtain 6 into 7 by 2. And this 6 will cancel out. So it is 7 by 2. And that is nothing but mean of given random variable is 7 by 2. Okay, this is nothing but this formula. Now if we go by definition, then variance of x is nothing but square of x minus mu into p of x. Now here mu is 7 by 2, so we put 7 by 2. We put mu equal to 7 by 2. And p of x is 1 by 6, so that we can take outside. So here I have directly taken p of x outside. Otherwise this is nothing but sigma x minus mu square divided by 6. X runs from 1 to 6. So here variable of summation is x, so we can take, in the next step we can take 1 by 6 outside, and we put mu equal to 7 by 2. Now in this we put x equal to 1, 2, 3, 4, 5, 6. Okay, so and we take summation. Okay, here for x equal to 1 it is 1 by 1 minus 7 by 2 square. For x equal to 2 it is 2 minus 7 by 2 square, and so on up to x equal to 6. And if you do the calculations, I have written directly the answer. You will obtain 35 divided by 12. So this is variance of given random variable using definition. Alternative method is we may use this shortcut formula, variance of x equal to expected value of x square minus mu square. So let us calculate variance using this formula also. This is by definition. So to use this formula, first we require expected value of x square. So expected value of x square is summation x square into p of x. X runs from 1 to 6. Again p of x is 1 by 6. So we can take 1 by 6 outside, and we have sigma x square. So we have to add square of 6 positive natural numbers, 6 positive integers or 6 natural numbers, 1 square plus 2 square plus 6 square. Okay, so here also we have this formula, sum of square of first natural numbers is given by n into n plus 1 into 2n plus 1 divided by 6. Now here we have sum of squares of first 6 natural numbers. So here we put n equal to 6. So 6 into 7 into 13 divided by 6. So 6 will cancel out and we will obtain 91 by 6. And mu is already calculated. Mean is nothing but 7 by 2. So we put values of expected value of x square and mu in this formula. So expected value of x square is 91 by 6. Mean is 7 by 2. So it is square of 7 by 2. So if you simplify this, you will obtain the same answer that we obtained by definition, 35 divided by 12. Now if I want to calculate standard deviation, I have to take square root of variance of x. So we put variance of x is 35 divided by 12, and this we simplify as this is 4 into 3, so square root of 4 is 2, so it is under root 35 divided by 2 root 3. So it is easy to calculate variance of a discrete random variable. Either you can go by definition sigma x minus mu square into px, or this is shortcut formula. First you calculate expected value of x square and then subtract mu square from that expected value of x square. We make one remark here, as we have made the remark for expected value of random variable. If you recall previous lecture, we have shown that expected value of linear function a into x plus b is nothing but a into expected value of x plus b. That means expected value of a random variable x is a linear function, but this is not the case for variance of a random variable. For variance, if we take variance of this linear function ax plus b, then it is not linear. It is given by a square into variance of x. Okay, you can prove this using the definition of variance. We are not going into the details of proof. So variance of ax plus b is given by square of a into variance of x. So variance of x is not a linear function. This is linear function. Expected value of x is a linear function, but variance of x is not a linear function because we are having a square here. This is in another notation we can write as sigma square corresponding to ax plus b equal to a square into variance of x. If we take standard deviation, then we have to take square root of both sides. So standard deviation corresponding to ax plus b is nothing but square root of a square into standard deviation of capital X, and we will put under root of a square equal to modulus of a. If we take square root on both sides, here we have standard deviation corresponding to ax plus b equal to square root of a square, that we write as absolute value of a into standard deviation corresponding to random variable x. Here we are writing absolute value because standard deviation can never be negative because it is a measure of scatteredness. So we can use this formula to find out variance of a linear function. Okay, in this example we are asked to find out variance of 2x plus 3 where x is a random variable in example 1. So in this example 1 we have calculated variance of x. Okay, this is example 1. So here we have calculated variance of a random variable. It is nothing but 35 by 12. So using that variance we can decide variance of 2x plus 3. So in example 1 we write that variance of x is 35 by 12. So using this property, variance of ax plus b is a square into variance of x. So if we compare with ax plus b, a is 2. So it is 2 square into variance of x. 2 square is 4 and variance of x is 35 by 12 from example 1. And this 4 will cancel out and we obtain 35 by 3. So if we know the variance of capital X, we can find out variance of linear function of capital X using this formula. We have to just take square of coefficient of x. Here coefficient of x is 2, so we have to take square of 2. Suppose instead of this function we have this x by 5 plus 7. Then if we take coefficient of x, it is nothing but 1 by 5. So we have to take square of 1 by 5 into variance of x. So in that case it is 1 divided by 25 into variance of x is 35 by 12. Okay, so this you can simplify. 5 will cancel out. So it is going to be 7 by 60. Okay, so this is very useful formula. Variance of a linear function is given by a square, that is coefficient of random variable x, into variance of x. We consider one more example. It is given that the n candidates for a job have been ranked from 1 to n. Let capital X equal to the rank of a randomly selected candidate, and PMF of capital X is given. P of x equal to 1 by n when x takes the value 1 to n, otherwise 0. So we have to compute mean and variance of this random variable capital X. So here PMF is already given. We can understand how this PMF is derived. Here random variable is the rank of a randomly selected candidate. So here candidates, there are n candidates and they are given the rank, that this candidate is first, this candidate is second, in that way. So they are already given ranks from 1 to n, and capital X is the rank of a randomly selected candidate. So if we select any candidate, then it can be any candidate from 1 to n, and the total number of outcomes is going to be n. So if candidate 1 is selected, then there are no chances of selection of remaining candidates. So outcomes in favor of 1 is only 1. Similarly, outcomes in favor of any of these 2, 3 up to n, outcomes are always 1 in favor of selecting any candidate. So probability of selecting any candidate from 1 to n is 1 by n, and otherwise we consider Px equal to 0 otherwise. So if we want to calculate mean or expected value of x, we use the definition. Expected value of x is sigma x into Px. Now Px is 1 by n for each value of small x. So here we put x by n. Now 1 by n is independent of x, so we can take it outside. And this is nothing but sum of first n natural numbers, and we have the ready-made formula n into n plus 1 by 2. So n will cancel out and we obtain n plus 1 by 2. So mean is nothing but n plus 1 by 2. Now the formula for variance is expected value of x square minus square of mean. So we have calculated mean, and now we calculate expected value of x square. So again expected value of x square is summation x square into p of x. So we put p of x equal to 1 by n, and that we can take outside because it is independent of x. Now this is nothing but sum of squares of first n natural numbers. So we have the ready-made formula for this, n into n plus 1, 2n plus 1 divided by 6. So here n will cancel out and we obtain n plus 1, 2n plus 1 divided by 6. So this is nothing but expected value of x square, and mean is n plus 1 by 2. So now by the formula, variance of x is expected value of x square minus square of mean, and this is expected value of x square that we have put here, and mean is n plus 1 by 2. So square of n plus 1 by 2. Now in these two terms we can see n plus 1 by 2 is common. So we are left with 2n plus 1 divided by 3 minus n plus 1 by 2. And if we take LCM here, suppose 6 is the LCM, then we will obtain 4n plus 2 minus 3n minus 3. 4n minus 3n is n, 2 minus 3 is 1. So this is going to be n plus 1 into n minus 1, that is n square minus 1 divided by 12. So this is variance of x. So in this way we can find out expected value of discrete random variable and variance of discrete random variable and standard deviation sigma of discrete random variable. So we just have to remember the formula for each of these. So I hope you like this lecture. Thank you very much.